All right, so we're going to go over how to graph quadratics. And this one, you just asked me for two different ones, so I'm going to talk about the first one. So the standard form is ax squared plus bx plus c. I know this is an equality. We're not going to worry about this right now. We're just going to think about it as just a normal. So the very first thing we do anytime we're graphing is we find the AOS, so where the graph is going to be split. So I'm going to go ahead and make a graph, and I have no idea how this one's going to turn out, so hopefully I'll make it big enough. I'm doing this kind of late for you, but that's okay. So if I notice here, I don't have anything that's a B, and I don't have a C. So if I think about what that means, if I don't have a B, I have nothing there, and I don't have a C, so it's like having nothing at all. Then if I put this as a negative B over 2 times A, this is my A, it's going to be a negative 0 over 6. Well, it doesn't matter. It's a 0. So I know it's hitting right here. This is down the middle is my AOS. So now I need to find my vertex. So that means I know that X on this one, X is 0. So that means in my coordinate, I know 0. So I'm going to plug in 0 into this. So I would get 0 squared. Obviously, 0 times 3 is 0. It would have to be here. If that was an equal sign, that means y would have to be 0. So I'm going to think about it as this way. So I'm going to think my vertex is right here. Now I need to go ahead and make my graph, my table. And if it's here, I'm going to pick a point 1 away and 1 away. So I'm going to pick 1, negative 1, 2, negative 2, and so forth. Okay, so I'm going to plug this into my problem. 1 squared is 1. 1 times 3 would give me 3. Negative 1 squared, still 1, times 3 will give me 3. So that means 1, 1, 2, 3. 1, 2, 3. I'm going to a 4 up, sorry. And then 1, 2, 3. So there's my 2 points there. Negative 2 squared. Oh, this should be a positive 2, sorry. This should be a positive. I have a negative 2 squared, so negative 2 times negative 2 is positive. So 4 times 3 is 12. Same thing would work here. So 3, 4, 5, 6, 7, 8, 9, 10. I'm going to be off the screen. So it's going to be up here somewhere. All right, so, and that's not really overly important. It's just how you know how to do it. Now, I made a solid line, but if we notice here, this is just a greater than. So this should actually be a dotted line. So let me undo my drawing here. This should be a dotted line because that means everything on the parabola is not included in our solution set. So now how do you know how to shade? Well, what I like to do is to pick a point that's not on the line, that's somewhere, that's an easy point. So if I look out here, like let's say out here, this 1, 1 right here, that 1, 1, it is not on the line, and it is not, it's clearly, obviously, not real close. It's not like a half or close to it. It's outside the line. So I'm going to plug it into this problem and see if it makes it true. So I'm plugging in 1, 1 into my equation. So that means when I have 1 is 1 greater than 3 times 1 squared. Well, 1 squared is 1. 1 times 3 is 3. Is 1 greater than 3? Well, that's not a true statement. That's false. So that cannot be shaded. That's not a solution set. So that means I would shade everything inside. All right, so the other one that you sent me was 0 is greater than 2x squared plus 3. So again, I have an A, I do not have a B, and I have a C. Well, if I don't have a B, automatically I know my X, my axis of symmetry, is at 0. So now I'm going to plug in to try to find my vertex. So if I plug in 0 into here, 0 squared is 0 times 2 is 0 plus 3. That means 0 is greater than 3. So that means my vertex is at 0, 3. So now I'm going to draw my little graph. And this is just basic part. Just ignore this part when you're graphing. originally to get your AOS and vertex and worry about that part when you go to shade. That's really all that you just act like it's an equal sign for now. So we have our vertex here. Let me get to a little bit smaller little highlighter, make my vertex or my AOS. So my AOS is right down the middle. And 0, 1, 2, 3 here is my vertex. Well, I know that it's positive, so it's going to be opening up. And I'm going to go ahead and make my table. So I'm going to pick 1 and -1, 2 and -2, because I just want to go very sequential side by side. So X and Y. So 1, -1, 2, -2. So I'm going to plug in 1 squared times 2 plus 3. So I get 1 times 2 is 2 plus 3 gives me 5. I'm going to get the same thing because these are symmetrical for -1. So I'm going to do it for 2. -2 squared times 2 plus 3. -2 times 2 is 4. 4 times 2 is 8. 8 plus 3 is 11. Again, I probably didn't make it big enough. All right, negative, I've got 1, 5. 1, 2, 3, 4, 5. And then this one will be exactly the same spot on the other side. They're symmetrical, 1 away, 1 away. And then this one is 2 and 11, so it's 5, 6, 7, 8, 9, 10. Ooh, barely had enough. All right, and this will be symmetrical as well. All right, so I've got them graphed. I need to now look at my inequality. So this is a greater than sign. It's not an equal sign. If it had an equals underneath, then I would make it a solid line, but it's not. So this is a dotted line again. That means all the values on this line are not solutions. They would not make this true. So I'm going to pick a point that's easy. Well, this one's super awesome because I can pick a point. Let me get to a different bright color here. I can pick a point that's way away. So I'm going to pick 0, 0. In fact, you can pick something easy, pick something easy. So I'm going to plug in 0, 0. So 0 is already here. That's our y. So 0 is greater than 2 times 0 squared plus 3. Let's see if that statement is true. 0 squared is 0 times 2 is 0, so this is 3. Is 0 greater than 3? No, it's not. So we can't shade out here. If this sign was reversed, then we could shade out here, but it's not. So we have to shade inside. Hopefully that's helpful. Let me know if there's some other specific ones or if something's still not clear, and we'll do something different.